Let's look at geometric sequences. We're going to identify geometric sequences and look at a general rule for geometric sequences and then sum of a geometric sequence. So in a geometric sequence, the ratio between consecutive terms is consistent, and this ratio is called a common ratio. The first term is always represented by the letter A, or by the term A, and the next term of the sequence is obtained by multiplying R to or by the previous term in the sequence. So let's look at which of these is a geometric sequence. So we get from 2 to 4 where we multiply by 2, 4 to 8 we multiply by 2, 8 to 16 we multiply by 2, 16 to 32 we multiply by 2. The other way to find this is to go 32 divided by 16 must be equal to 16 divided by 8, which must be equal to 8 divided by 4, which must be equal to 4 divided by 2, which must be equal to 2 divided by 1. This must be true for it to be called a geometric sequence. In this case, it is true. Now let's look at this from 1/4 to 2. Well, let's do it this way. 16 divided by 4 must be equal to 4 divided by 2, which must be equal to 2 divided by 1/4. So let's look at the results here. 16 divided by 4 is 4. 4 divided by 2 is 2. 2 divided by 1/4 is 8. So this is not a geometric sequence. Now let's look at this example here. So 12 divided by 6 must be equal to 6 divided by 3, which must be equal to 3 divided by 3 over 2, which must be equal to 3 over 2 divided by 3 over 4. So 12 divided by 6 is 2, 6 divided by 3 is 2, 3 divided by 3 over 2, so that's 3 times 2 over 3, so this is 2. 3 over 2 divided by 3 over 4, so 4 divided by 2, so this is equal to 2. So this is a geometric sequence. Now, when we want to find the nth term of a geometric sequence, we multiply the first term by the ratio to the power of the nth term minus 1. Let's apply that and see how that works. So let's write out our expression first. The nth term is A multiplied by R, which is our ratio to the power of n minus 1. So the fifth term is going to be, first we identify our A is 1/4, and our n, if this is a geometric sequence, our n is going to be 2 over 1 equal to 1 divided by 1/2, which is equal to 1/2 divided by 1/4. This is going to be equal to 2. So our ratio, common ratio is 2. So the fifth term is A, which is 1/4, plus, or rather multiplied by 2 to the power of 5 minus 1. So this is going to be 1/4 multiplied by 2 to the power of 4, which is 1/4 times 16, which is equal to 4. We can see here that the fifth term will just be 2 multiplied by 2, which gives us 4. So that's the way to check that. Now our 13th term, T13, is equal to 1/4 multiplied by 2, which is our common ratio, to the power of 13 minus 1. So this is 1/4 multiplied by 2 to the power of 12. Now I'm going to apply some exponent rules here to make this a lot easier to deal with. So this is going to be 2 to the power of negative 2 multiplied by 2 to the power of 12, which is 2 to the power of negative 2 plus 12, and that's going to give us 2 to the power of 10. If you want to simplify that, that should give you 102. Now for this sequence, let's establish what our common ratio is. Now the nth term is given by a multiplied by ratio to the power of n minus 1. So our first term, a, is going to be negative 1 over 3. Now we want to find our common ratio. If this is a geometric sequence, what we need to do is we have negative 16 over 3 divided by 8 over 3. That should generally give us our ratio. So let's do this. So it's negative 16 over 3 times 3 over 8. So this is negative 2. So the eighth term is going to be, so T8 is going to be a, which is negative 1 over 3 multiplied by negative 2 to the power of 8 minus 1, which is negative 1 over 3 multiplied by negative 2 to the power of 7, which is going to give us negative 1 over 3 multiplied by negative 128. So this is going to give us 128 over 3. For the 13th term, T13 is going to give us negative 1 over 3 multiplied by negative 2 to the power of 13 minus 1, which is negative 1 over 3 multiplied by negative 2 to the power of 12. So this is negative 1 over 3 multiplied by 4096, which is 4096 over 3, and it's a negative value. Now when we're trying to find the sum of a geometric series or sequences, here we are multiplying a, which is your first term, by 1 minus r to the power of n over 1 minus r. So let's apply this to some examples. So we have s to the nth term is a 1 minus r to the power of n divided by 1 minus r. So this is what we're working with. A is 1/2, and our ratio, let's get our ratio, is going to be negative 4 divided by 2, which is negative 2. So let's look at the sum to the 10th term is a, which is 1/2, multiplied by 1 minus negative 2 to the power of 10 divided by 1 minus negative 2. Okay, so this is going to be 1/2 1 minus 1024 divided by 3, which is because it's 1 plus 2. So this is going to be 1023 negative 1023 divided by 6, which is going to give us negative 341 over 2. And if we want to simplify, we can simplify it to be negative 170.5. Now for this geometric sequence, we have our sum to the nth term is our first term 1 minus r to the power of n divided by 1 minus r. So let's look at our a is equal to 1, and then we need to find our r, which is going to be 1/2 divided by 1, which is 1/2. So let's find the sum to the 10th term. That's going to give us a is equal to 1 multiplied by 1 minus 1/2 to the power of 10 divided by 1 minus 1/2. So this is going to give us 1 minus 1 over 1024 divided by 1/2. So this is going to be 1 divided by 1/2 is going to give us 2 multiplied by 1024 over 1024 minus 1 over 1024. So this is going to be 2 multiplied by 1023 over 1024. This is going to give us 1023 over 512. And so this is the sum to the 10th term of this sequence.